Between 2014 and 2018, the number of measles cases reported in the US is approximately parabolic. See the graph. So we're looking from here to there. And yeah, it does kind of look like a parabola. Determine a quadratic regression for the number of measles cases reported in the US from 2014 to 2018. Okay, so I'm going to call 2014, I'm going to call that year 0, and I need that number, which looks like it's 667. And then year 1, year 2, year 3, and year 4. So I got to read the graph and get all those numbers. And then I'll enter that data into decimals. So I've entered that data into decimals, but I don't see the graph because I have a poor window. So I need to change my window. Let's see, the x numbers only need to be as big as 4. So my x values all go -1 to 5 maybe. And then my y values, I need to go at least to 667. So I'm going to go -100 up to 700. And now I can see my data. That's better. All right, so now I get my quadratic regression. y1 twiddle, ax1 squared plus bx1 plus c. And let's see, I'll write that down on the paper. So y equals 114x squared minus 522x plus 646.4. And we can see it doesn't fit the data great, but it's not horrible. It's off a few of the data points, but pretty close to a couple of them. Okay, back when I was writing this question, there was a lot of news coverage about the number of measles cases in 2019. The claim was that the number of measles cases is unusually high. According to the regression, is the number of cases in 2019 unusually high? Well, 2019 would be year 5, x is 5, and so I would take 5 and plug it in, and when I did that, I got 886.4. Now, if you can read that, up there it says 940. So is that unreasonably high? Depends on how you want to look at it. Again, keep in mind that this equation did not match perfectly, so you might say, well, 886 and 940 are not off by a lot. Or you could say, well, I guess they are off by quite a lot. Depends on your state of mind, I guess, at the time. All right, our last question in this section. A graph of a flight profile of the Rexus 17 sounding rocket is given below. Notice that the flight of the rocket was very parabolic for the first 250 seconds. At approximately 250 seconds, a parachute opened right here and dramatically slowed the rocket. So you can see it slowed down dramatically after that. Determine a quadratic regression for the flight of the rocket during the first 250 seconds of flight. Okay, so again, this time I'm going to have to read my graph. I notice I have points like 0, 0, looks like 50, 40, 180, so on and so forth. So let me go and enter that data into decimals. So here's the data that I got. Once again, we have to change our view window this time. We need the x's to be at least 250. So I'm going to go from minus 30 maybe up to 300. And then our y's only need to go to a little more than 80 but less than 100 looking at the original graph given. So I'm going to go minus 10 to 100. And we can see our data. We can now compute our regression. y1 twiddle, ax1 squared plus bx1 plus c. So y equals minus 0.004 x squared plus 1.24x minus 3.90. All right, according to the regression, what was the maximum height of the rocket and when did this occur? The maximum happens at the vertex, so we can use x equals negative b over 2a. That's negative 1.24 divided by 2 times negative 0.004. Using my calculator, I got 155. I plugged 155 in for all the x's, and I got 92.2. So this would be the units here. Not sure. This one is kilometers, not feet. And what are the units here? Seconds, it looks like. So it happened at 155 seconds, and its maximum height was 92.2 kilometers. Assume the parachute had failed to open. According to the regression, when would the rocket hit the ground? It would hit the ground when its height is 0. So 0 equals minus 0.004x squared plus 1.24x minus 3.90. Use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2a. And I'll grab my calculator, type that up. According to my calculator, I got 291.265 and 3.179, but I think we need to throw this one away. And this is a good example of our regression does not perfectly match. We know that the rocket started from the ground. It started at height 0 and it went up. There's no way it hit the ground in 3 seconds. So we have to throw that one away. And it does seem like 290 would be somewhat reasonable. It's definitely beyond 250. Seems like a fairly reasonable number.